Hello there, it's Jay here from Jay's Vintage Junk, and this is going to be part 2 of the 48K Spectrum repair and refurbishment. And I've just been doing some work on it actually. I said I'd just finish off changing those caps off camera, and then we'd get back to it and we'd see if we could have a look at that ram fault. And I've got this horrible feeling that I might have just accidentally fixed the ram fault while I was changing the capacitors. I'll get you down on the board and I'll show you what I've spotted and what makes me think that could have been the issue with the ram fault. So we'll just get you set up actually down here on the bench. Okay, so we've got you set up on the bench so you can have a look at the board. And as you can see, I've changed those 3 capacitors I didn't change in the last video. And as I was changing that one here, I'll show you on the back. Basically, as I was swapping that capacitor out, and we've got a point there and a point there, I noticed on this IC there was a dry joint on that pin there. So I wasn't even thinking about it at the time. I just thought, oh, dry joint. So when I resoldered the new capacitor in there, I just put the iron on it and just reflowed the joint with a little bit of solder. And then I carried on, and like I said, I changed the other capacitors. And then I thought, now that IC, it is IC25 there. Is to do with the decoding for the upper bank of RAM. So I'm wondering whether having that dry joint there was taking out some of the decoding for the upper bank of RAM here, and that's why it was only booting up as a 16K machine. Now I haven't actually tried this yet. What we'll do is I'm going to just do a couple of final bits on this board while I've got the iron hot and the desoldering station set up, and then I think we'll get this set up. And I've got a memory test program. It's if you've ever watched Jules per Coulomb's YouTube channel, he hasn't actually done anything on his channel for about 4 years now. But he did some very good ZX Spectrum repair videos, and it's a little program that he wrote for testing the upper and the lower banks of memory. In fact, you can actually download it off his website, and I will put a link to that down in the description of this video, because it's quite a useful little piece of software for sorting out memory problems on these Spectrums. So we'll give it a go with that, but what I thought we'd do first, now I've changed all the capacitors. I did get at least one comment from someone saying it's not necessary to change all the capacitors on one of these, and in some ways I agree with them. Yeah, if it was a Spectrum in my own personal collection, to be honest, I would have tested all the capacitors, and any that were really out of tolerance I would have changed, but I'd have left it at that. This isn't my computer. This is going to someone that they mess with cars. They don't really mess so much with electronics. I want them to have a reliable computer. I want them to have a Spectrum that they can play with and enjoy. I don't want to have them to have a Spectrum that they play for a few weeks and it breaks down and then has to be sent back to me, or has to be sent to someone to be repaired again. And even though changing all the capacitors isn't the be all and end all, you could still have a transistor fail, or you could have the ULA go, or a RAM chip go. But it's just one thing that you can do, which is basically preventative. These original capacitors, these when we were installed in 1983, they are old capacitors. Yeah, they're showing okay for capacitance. Their ESR is getting a little bit high, but it's still in spec. But what I bet isn't on these is the leakage current. Again, if you watch Jules per Coulomb's video on changing capacitors in these old Spectrums, It's something that he brings up, that they can show reasonable for ESR and even reasonable for capacitance, but the actual leakage current of the capacitor can go way up. I'm not going to do it in this video, but I will do a separate short little video of basically the same experiment that he does, is where we put a voltage well under what the rating of the capacitor is across it, and we actually measure what the leakage current on these old electrolytic capacitors are. And I'm pretty sure at least one of them, basically that 100 UF that we actually had a split in the plastic there, I think we'll find that the leakage current on it is quite high, and that was actually, you know, getting warm in use, which is what you get when you get leakage current, and hence why the jacket had actually split on it. And anyway, with that in mind, like I said, this isn't my computer. This is going to someone, like I said, who just wants a Spectrum that they, you know, they can play the odd game on every now and again. Another part that I'm going to change is the 7805 there, voltage regulator. Purely because, for one thing, it's looking a bit iffy. Someone possibly changed it in the past, or at least had this heatsink off in the past, and when they've done it back up, they've twisted it and they've bent all the legs on it. Like I said, I had to redo one joint straight away because we had a cracked solder joint there from the start. I don't believe they've used any heatsink compound or anything under it when they actually changed it, and I have a big bag of brand new ones, so, you know, it's just for a bit of future proofing. I may as well put a brand new 7805 voltage rig. What do these cost, you know? Well, like 50p, 40p, something like that. You know, it's just something that if it is the original, or it's at least had some heavy use, it's something that could fail in the future, which for not a lot of effort we can just swap out, and you know, we've alleviated that problem. So with that in mind, we'll get the heatsink off. And this, also, I want to take the heatsink off as well, because one of the things I just want to do now is actually clean the edge connectors, because they are pretty dirty on this particular Spectrum. And again, that's going to affect things like the joystick adapter. Oh, that's another thing. This is a brilliant thing about YouTube. You find things out that you didn't know. I mean, I've been playing with old 8-bit micros since the 90s. I mean, I've had one since, you know, the 80s. But I actually got into repairing these things while I was still at secondary school in the 90s. Apparently, these are not ZX81 joystick adapters. Apparently, there's a good possibility they'll work on a ZX81. But it was basically the manufacturers cheaping out a little bit and realising that for the joystick interface you didn't actually need the whole width of the Sinclair edge connector. So they just used the shorter connector, which just, obviously it's got a keyed pin so you can't put it on wrong, but you still pick all the pins you need to for the joystick interface up there. So with that in mind, well actually, this is faulty. What I did with that in mind is I went through my box of joystick interfaces, and I found a couple which I thought was ZX81 interfaces, but they're not. The Spectrum. That one's a Kempston interface. That works absolutely perfectly. The one that came, the DK-Tronics one that actually came with the Spectrum, actually, fire and left and right work fine, but up and down don't work. So we will have to have a look at that a little bit later on. But if I can't fix that one, I've got one I could just throw in there. But these things are dirt simple. I don't think I'm not going to be able to repair that, to be honest. Anyway, let's get back to what was doing, because I'm getting distracted. What we was going to do is we were going to swap out that 7805 with a brand new one. I'll get a suitable bit for my driver. That'll do. We'll get the heatsink off. We'll hold the nut on the back and just... That is tight. Dear me, that is very, very, very tight. Let's see if we can... have to free it off from the back there. Boy, whoever put that on didn't want it coming off again. That's probably why they strained the reg while they were doing it. Let's get that up and off. There we go. Just lever that up and take the heatsink off there. In fact, they've not even got the washer in the correct place. That should be under the nut, not under the head of the screw. And no, they haven't put any heatsink compound on that. We'll get that old one off. Like I said, we'll fit a nice brand new one on there. Okay, that should be that off. That way. There we go. And we'll walk that one out. You can see what's happened to the legs on that. You see it's all smushed out of space. Let's put a nice brand new one on there. Where did I put it? There it is. Now, when you fit in these, you need to form the legs before you fit them down, or else they don't actually fit very well. Let me see if I can demonstrate with this one. I've not done this in a while. But basically, you want to bend the legs where they just start getting thin there. Bend them actually underneath. So further than they need to go, and then a little bit further down you kind of bend them back, and you end up with basically that. I don't know if you can see that. So the legs basically come out and then go back under themselves and then come down. If you don't do that, when you actually fit these regs, it's Sinclair. They didn't design the board very well, and basically you have to help the 7805 to fit correctly. So that's essentially how we want it. What we want to do is we want to put a little bit of heatsink compound, not underneath there, because we want that well grounded. We've got some heatsink compound here, and we don't need very much of it. We literally need a tiniest bit. I see people put far too much of this stuff on, and it's not necessary. You literally just need the tiniest little spot. I mean, you can, yeah, you can always clean it off, but it's messy stuff, this. That's enough. That little tiny bit there is enough. You don't really want it going everywhere, because it does. If you get it on your clothes, it goes literally everywhere, that. Right. We've got that ready. We mount the heatsink on, the reg onto the heatsink like that. Put the screw through, and if we're right, we should be able to line up those through there, and quickly drop that into the hole there. We got that in right? No, we've just not quite got that right yet. Where are my glasses? I should really have my glasses on for doing things like this. There we go, that's better. Right, let's put this back in then. There we are. That's them poking through nicely. Then we put the washer on there and the nut on the washer. That's an anti-vibration washer. The idea of that is that it helps to stop that nut from undoing. It doesn't do much good up there on top of that screw. Right, we need to make sure that those are nice and tight before we screw that. We do this before we fix the reg down. Give that a turn. Make sure the reg, well, you know what I've done? I've done that before I've cleaned that connector. I say I was going to clean that connector before I put this back on. I'm an idiot, aren't I? So we undo that again. It's a good job I hadn't soldered the reg into place and then realised what I'd done. I would have looked a fool. Right, let's take that back off, but we've got that ready to go. And put that to one side. And now while we've got access, we can clean up this edge connector here because it really is quite nasty on this specky. I'll grab my fiberglass pen, and I'm hoping with a little bit of work with the fiberglass pen, this should actually come right again. Yeah, that's coming. These pens are brilliant. They really, really are. In fact, I'll just quickly do half, and then I'll zoom you in, and you can see the difference between the connectors that I've actually cleaned with the fiberglass pen and the ones that I haven't touched yet. Let me just zoom you. Well, you can see that straight away, can't you? Wow. There you go. There's an idea. You can see how tarnished these are here, compared with where I've just cleaned it with the fiberglass pen. So we'll just carry on and do the rest of these, and then we can fit that heatsink and the reg back in. So unfortunately, I'm left-handed, so it's rather tricky for me to show you this with where I've got the camera right now. You can just see how much of a difference we've made there. I've just got these little ones at the end to do. Yeah, these fiberglass pens are worth every penny. And they're not expensive either. I think they were £4 or £5 for a set of 3. I've got the fiberglass one, I've got a little brass one and a little steel one. So the brass can be good when you've got some really nasty corrosion to get rid of. The steel's good if you've got some actual rust to get rid of, but if it's just tarnishing on contacts like this, you cannot beat this fiberglass pen. The others are a little bit harsh for doing this kind of work. There we go, look at the difference there. Right, I'll get you zoomed back out. And don't worry, we will do the... In fact, we'll do it now, can't we? Yeah, we will. We'll do it now. Let's do the other side while we're here. And then they're done. We don't have to worry about them. I don't forget about them. So this should make plugging in the joystick adapter a lot better. Unfortunately, that isn't the fault with it, though. I didn't test it on this board. I tested it on one of my test spectrums that I've got set up. So I know it weren't just a contact issue or anything. There we go. Look at the difference there. You see how shiny that is now? So we shouldn't have any contact problems. Right, let's get back to putting that new Regan heatsink on. Get them lined up again. And through the roll. There we are. Get in your hole. That's 2 in. Let's get this last leg just to pop in its hole, and we're good. It's typical, you get it all in the first time, then when you have to pull it out. There we are, that's it, that's in. And we'll just hold that with my finger. Get the washer on. Get the nut on that. Just give that a quick. Lined up. Make sure everything's nice and square. We'll give that, just hold the nut with that. We'll give that a final twist and a tighten. There we go. That's nice and tight now. Make sure that is lined up. We don't want to undo it again. Make sure everything's nice and square there, as we can see. And we just need to solder the reg into place. Just leave my hair enough. There we go. Just make sure that those are nice and flush, which they are now. And there we are. That's new reg installed. Then that's just a little bit of future proofing, really. So we've got all new capacitors, like we've mentioned. We've got a new voltage reg. I won't bother changing the DC jack connector there because there's absolutely nothing wrong with it. It's not even particularly dirty. I'll just give that a really quick clean with the fiberglass pen, but that is pretty much fine. What I think we should do now basically is give it a test. Like I said, I think what we'll do is we'll get it set up and we'll run that memory test program on it. That should see if that was indeed the issue with the upper RAM. I have a feeling it was definitely a, like I say, I'm just a bit annoyed that I didn't stop where as soon as I saw it and thought, but I didn't actually realise till I flipped the board back over and thought, oh, IC25, that's to do with the upper RAM. I wonder if that was our issue. Anyway, I'll just get us all set up and we'll come back and we'll have a quick play with this memory test program. So back in a sec. Okay, we're back and I've got the specky board all connected up, so it's connected up to my monitor screen up here. It's connected up to power. I've also got it connected up to this tablet here, which I've got the memory test program on. So I'm basically just using this like a virtual tape player. I'm using my test keyboard here because it just makes life easier than having the membranes basically hanging out and risking damaging them. This is just it's a nice elegant solution when you're working on like 48k specky boards. I had it lying about, so I use it. You know, it's one of those things. Anyway, let's switch the we'll switch the specky on and we'll see whether it's actually going to boot up. We indeed do have a spectrum which is fired up. So what we will do, we go load, double quote marks, press enter, and then I'll run the memory test program. It's a very short program, little machine code program, so it only takes a few seconds to actually load it. So we'll press enter there. And I'll start the it's 28 seconds to load, so as specky software goes, like I say, it's a pretty fast loading piece of software. That's it, basically. And like I say, it allows us to test the upper and the lower RAM. Now, I'm pretty certain that there's nothing wrong with the lower RAM, well, one thing being that it can actually run the software. But we will test the lower RAM first, and if it's okay on the lower RAM, we'll go and give it a upper RAM test. If it passes that, we might even see if it'll run some software. So let's try a lower RAM test and press enter, and if you look, it goes by its mem test C, configuring test for lower RAM. This is on pass 1, and basically what it does is it writes random numbers to the memory, then reads them back, and it compares what it's wrote to what it's read, and obviously if there's a mismatch, it finds an error and it'll throw an error up. It does take quite a while to run. We'll just run it through a couple of stages now so you can see what it actually does. Then what I'll probably do, I think I'll just pause the video and I'll leave it running for perhaps an hour or so, and we'll see how it does, and then we'll come back and we'll have a go at the if it doesn't find any errors on the lower RAM, we'll give it another go on the upper RAM bank and see if it can find any problems there. So I'll come back after this has done a few more passes than it has now. And that pretty much confirms that our lower RAM is indeed okay. As we can see, using that memory test program, we've got to 172 passes. You know, I've had it running a couple of hours now, well, at least an hour and a half. So it's looking like as I thought anyway, the lower RAM is good in it. So the next thing we really need to do is run the software again and run the same test and basically test the upper RAM, and that's where I think we'll possibly find a fault. But depending on what this shows, will give us an idea where the actual fault is, whether it's actually one of the DRAMs that's at fault, or perhaps it's something to do with the multiplexing of the RAM. There's some 74 series logic there that's used for the multiplexing for the upper RAM. That could be the issue, but it certainly looks like we've got good lower RAM. Like I said, that's ran absolutely perfectly, no issues at all. So let's get back and we'll do the other RAM in a sec. Okay then, let's try it again for the upper RAM. So as I did before, it's just a case of pressing J, which is load, then symbol shift quote mark, press enter, and then we just press play on the tablet. And we'll get you up on screen. Okay, then this time we obviously want to test the upper RAM, so U, press enter. And this is basically going to do exactly the same thing to the upper RAM. Now, this is a longer test. Obviously, on the lower RAM test, you're only testing 16 kilobytes of RAM, as where on the upper test you're testing 32 kilobytes of RAM. So the RAM test actually takes longer to complete. We'll let it run through a pass here now, and then I'll leave it running. I'll probably leave it running, I don't know, an hour, and just see if it comes up with any errors. I mean, that should give us a fair number of actual tests, and if it hasn't actually errored out in that time, we can be reasonably confident that it's probably going to be okay. And then we can actually, we might even try loading a game up or something, loading some software up, see how it does with that. I mean, we've got the keyboard connected up and everything, so we can actually try that, and we'll carry on from there. So I'll pause it now, and I'll come back either if it crashes or whether we can get through an hour or so and it hasn't come up with any RAM errors. So back in a sec. Okay, so the upper RAM test has been running for quite some time now. As you can see, we're up to pass number 32, and it's still going strong. It's absolutely rock stable. So I really think that was probably the well, that must have been the issue. Instead, we just had a little bit of a dry joint there. But yeah, that's looking really good now. So I suppose the only thing really left to do is try it with some games. I think what we'll do, we'll try it with a 16K game, get that to load up, and if it's happy with that, we'll try it with a full 48K game, and we'll leave it running something and just see how it goes. So I'll be right back when I've got the game set up. So back in a sec. Okay, well, I've had the Manic Miner basically running on it now for the best part of an hour, just playing to itself, and we've not had a single glitch. So I honestly think that's all it was. It was just a dry joint on that 7400 logic chip. I'm absolutely, I mean, sorry to you guys, I was hoping we'd have a decent RAM repair there, but I mean, it means I can get this computer buttoned up and back to the chap ASAP. We're not going to have hours and hours of diagnostics on this. I'm just going to check the, you know what, for a ULA, that ain't running too hot. I mean, I can feel it. I wouldn't like to leave my finger on it much longer than I've got it on it now, but that's not too bad. So feel the CPU. Amazingly, the CPU is barely even warm. Now I will say, this isn't the warmest of rooms, and it's a much difference having the board just out on a bench like this than it is when it's actually in the case. You know, this is what causes the problems, especially with the the rubber key 48K. Actually, when they brought the Plus model out, it was far better, even though basically it's the same computer, it's the same board essentially. Because there's more room in the case, you don't seem to have as many 48 Plus failures as you do the rubber key 48K. I am going to do something at least to help that. I've got some heat sinks I'm going to put on the CPU and on the ULA. In fact, we'll stop Manic Miner now. We'll get my test keyboard disconnected and get that out of the way. Get it unhooked. So that is basically ready to go into its case. We'll get the base and we'll stick the computer back into its case. Get that lined up. In its right hole. There we go, that's the Spectrum back into its case. Now, one problem with the 48K, like I said, it's real. You really want to put a heatsink on the ULA. The problem is, the standard little heatsinks you buy that people use and they put on the CPU, yeah, that will fit on the CPU. Because of the amount of space that you have in the 48K case there, you can't actually fit one of those heatsinks onto the top of the ULA. The case won't actually go on it. Now, what I used to do, years ago, I bought a massive load of spare parts for these old 8-bit micros. It's what's kept me going all these years, actually. And in amongst that, I got a load of really slimline heat sinks. I think they're intended for the video chips in MSX and other computers, because I have seen that type of heatsink on the top of those. And they were just thin enough that you could put them on top of a Sinclair ULA in one of these 48Ks, and the case will go on. Unfortunately, I've run out of them. I ran out of them a little while ago, and I was been thinking about a solution. I had some thin aluminium plate, and it's just a little bit thinner than the plate that the heatsink there's made out of. And I had been using that cut up to make heatsinks for the ULA. And I thought I still had some of that left, and I actually made a heatsink. The problem is, this is actually a thicker aluminium, and with that on top of the ULA, if you actually look, and bear in mind that that is thinner than the heatsinks that you buy. If you look, the computer won't actually go together even with that heatsink on. So I was having a think, and down in my workshop I've got loads of little offcuts of copper pipe, and as we know, copper is a very good conductor of heat. So I made one out of a piece of copper pipe. Basically what I did is I pounded a piece of copper pipe on my little anvil flat, so it was like that. I then cut some slots in it. These just help dissipate the heat. If you ever look at heat sinks, you'll see that they have fins cut in them. It just helps to dissipate the heat. But even that, so I had it double thickness like that. Even that was too thick. You still couldn't get the case on comfortably. It fit, but you could tell you was straining it. So all I did is I took it back down into the workshop and run it on the bench grinder and ground along there, and ground along there, and just split it in half and made two. So we've got a little copper. Like I said, copper is a very good conductor of heat sink, which can just go onto the top of the ULA then. And rather than waste it, I'll use that one, and we'll fix that one to the top of the CPU like that. So the CPU isn't as critical. It's a Z80. If it fails, I've got boxes and boxes of Z80 CPUs, brand new all stock ones. Excuse me. I do have spare ULAs, but that is a finite resource. I know you have the modern ULA replacements, but if you want to keep with originals, you know, Sinclair parts, I do only have a finite number of replacement ULAs. So we do want to try and preserve them. Because this is someone else's computer, and obviously, you know, I'm trying to make it last as long as possible, as long as we can. It does make sense to put a heatsink on the CPU there as well. So we'll get these heatsinks mounted up. Let's get the and I've just put it's a it's a conductive adhesive tape that you can buy. It's specially designed for use on heatsinks. It is a bit of a faff to get off. Hang on, let me just get a screwdriver so I can peel the right, peel the backing off. And the one I've got is a little bit thin for this size of heatsink, so I've had to use a couple of strips of it next to each other just to make up the surface area that we want to cover. There we go, as you can see that's stripped off. A little speck of something on top of the CPU there, we'll get rid of that. You just want to line that up so it covers the die on the CPU basically. And then we'll push that down into place like that. Like I said, that will just help dissipate heat off the CPU. And we'll do the same with this one for the ULA. There we go. Just peel this off the back of that. And we will just make sure we get that stuck nice and central on the ULA like that. We'll just stick that down. And that should help dissipate the heat off the ULA, which will hopefully prolong its life somewhat. And there we go, that's pretty much the work to the actual 48K done. So like I said, we've done a full recap on it. We've fixed that RAM problem with the upper 32K of RAM. We've put a new 7805 on there just as a precaution. Like I said, the other one, someone had, when they was tightening that screw, they'd not held it properly, and they'd actually allowed it to shift like that. Like I said, it had bent all the legs, and it actually had caused a dry joint on one of the legs there. So we've sorted that out. We've done the composite mod on it, so it can actually be used on a more modern TV. So that, as far as I'm concerned, is pretty much ready to go. What we do need to now address is the keyboard, because unfortunately we did have a membrane failure. Now it may actually be possible to clean that off and get it to attach. It's right on. It is just possible to do, but I'm not going to go down that. Like I said, if it was one of mine, and I'd possibly risk getting a little bit more life out of it like that, but they're only 10 quid. I've got a brand new keyboard membrane here, produced in I think this was a 2019 manufactured one, or 2018, sorry. It was 20th of the 5th 2018 manufactured membrane, so we will be installing that. And like I said, that should give another at least another 30 years of key bashing. The biggest problem we've got with fitting that, and it pains me to do it on a keyboard this nice, but we've got to take the metal off the keyboard to actually put that new membrane in there. What we'll probably do is we will, in fact what we will do, we'll get that out of harm's way for now, so we've just got the keyboard to work on. We'll get some implements out. Now where So just bear with me 1 second, folks. Okay, we are ready to proceed. And basically, what we're going to do is we're going to try and warm this up to help release the glue, and then we'll go in with. I'm going to try this. I have a one of them little spudgers that came with a mobile phone repair kit to replace the screen on the phone, and I have just spent half an hour looking for the damn thing, and I cannot find it anywhere. But hopefully that should do the same job. It's literally just to get something that you don't want to use something metal, because you're going to risk actually marking the paintwork. But we just want something we can get under that lip there to help when we start levering this to get this actual metal plate off. Once you get it started, actually, it's not too bad. It's getting it started that's the hard bit. Heat wise, I mean, you could use a hairdryer. In fact, probably a hairdryer is the best thing to use for this. I'm going to use my hot air station, but I've got it turned down as low as it'll possibly go. I've got the airflow turned down on it, and I've actually taken the nozzle off the end of it, so it's just open air. If I use it quite a distance away, I should be fine with that. Like I said, you don't want to use a paint stripping gun or anything like that, because you'll end up warping the plastic or damaging the paint, or you'll do some damage to it. You do need a lot of care for doing this part, especially when it's in such nice condition as this one is. And we'll get the hot air. So I'm going to stay well away from it, and we're just going to keep the hot air. You do want to warm the whole thing, but that's not too bad. If I can keep my hand under it like that at this distance, we know, it's not going to be too hot. All we're literally trying to do is get that old adhesive which is holding this front plate onto the keyboard off. And just keep feeling it, make sure nothing's getting too warm. That's just warming up. Keep applying your heat. We do need it all off, so we do need to get all the adhesive warm. Pay particular attention to the edge you're going to start with. Feel how that's just warming up nicely, that. Alright, let's give that a first. And you want to work quick, so you want to work while it's still warm. Just go in. It's just starting to lift. See that there. You see that there? It's working the edge. Well, there we go. Hopefully we didn't leave a crease mark when that come up then. You see that starting to lift there. It's still stuck along that bottom edge there. So let's get the heat back on. Hopefully you can see what unfortunately I'm left-handed, so that does make doing this and showing you a little bit tricky. But basically, if we just lift, and this is where the holistics come in very handy. And also an assistant can be very useful as well. It is a lot easier to do this with another pair of hands, but basically we lift and we just slide that under as we lift. There we go. You see that? Get right to the end. And so I'm just using the heat to help. We don't want to beggar it up at this late stage. But the heat really does help with this. And there we are, we're off. Let's just get rid of that. Pull that off finally. And as you can see, we've got the metal work off without any damage to it at all. I'll just get this bit of old tape off, and you can see where it was stuck. We've got along there, along there, along there, and back down there. That's where we'll apply the new tape to when we get that far. Now let's just get that out of harm's way, because we don't want to risk damaging that. Now is a really good opportunity to clean all the mank that's built up over the years out of this rubber. So we'll lift that off. Let's have a go with this. Just give it a nearly 40 years of grease and fluff and skin in here. Think how many sticky kids' fingers have been on this keyboard over the years. In fact, what I might do is just go and give that a quick proper wipe down, because it is quite manky. So back in a sec. Okay, I left that to soak in some very mild detergent in some warm water for about 30 minutes, and then give it a very light scrub, and basically just got rid of any of that muck and grease that was on there, and all the fluff and mess that was inside there. And so it's actually come out pretty much like new. It's actually in really nice condition, that membrane, sorry, that rubber mat. Right, what we are going to have to do is we're going to have to clean off this old tape here. And actually, one of the easiest ways of doing it is like this. You can literally, depending how old it is, sometimes I've seen this and it's actually gone crispy, and you have to clean it off, use a little bit of WD-40 and a Q-tip, and it can take ages to get off. Sometimes like this, the tape's still fairly soft and supple, and you can literally just roll it off with your finger. You just roll along it with your finger like that, and you can just roll it off like that. Sometimes it takes just to take a screwdriver. Now you will never see this bit, so it won't matter if you scratched it. You just do have to be a little bit careful and just clean off all the old adhesive. And obviously we have to do this to the underside of the metal plate as well. The problem is, if you leave any of this on when you apply the new adhesive, the new adhesive's not going to sit level, and the plate is actually never going to sit completely flat. I've seen it before where people have done it and they've not taken the old tape off, and you can tell, like I said, the plate never sits right again. But basically we've got all that off there now. We can get the old keyboard membrane out. It's pretty yeah, it's pretty bad, that. That's the old one there. And here's the new modern replacement. It's exactly the same size as the old one. All the things are exactly the same size. Slip that in there like that. Whatever you do, make sure you put it in the right way round. So you want the larger tab to this side and the smaller tab to that side. So small tab to the left, large tab to the right. So that's the new membrane in there. And we can put the rubber mat back on. And make sure you get the rubber mat set correctly. Make sure it all fits in properly before you attempt to try and put the metal plate back on. You can see that's all sat down nice and flat in there now. Now we've got, make sure I've got nothing that I can mark this plate with on my desk. In fact, have I got anything I can just put down? In fact, yes I have. So I don't want to risk marking this plate while I work on it, because it is absolutely perfect. So I'll just put something down like that, and we can put the plate face down, and we can just start working on getting this, getting the old tape off. And we can perhaps risk using a razor blade here, because it doesn't matter if we put a slight mark on the back of here, no one will ever see it. But we do need to get all this tape off, like I said, then we can apply a new tape to it. Anyway, you get the idea. I will come back to you once I've got all this sticky horrible tape off, and we can get ready to actually reapply this to the Spectrum. Okay, that took me the best part of 30 minutes to get that old adhesive off. That was horrible. I ended up using IPA, Q-tips, a razor blade, all sorts to get it off. Anyway, as you can see, I've applied the new double-sided tape. It's dead simple. Literally, you just tear it off, peel off the backing. Make sure that none of it is sticking over the edge, whatever you do, or else it's going to look horrible when you stick the actual plate down. Like I said, just make sure that you've got none of the adhesive showing over the edges. Peel all the backings off. Got a little bit there we can just fold in. Take the last piece off. There we go. And that is now ready to reapply. I'll get the case back in. Put it down, make sure it's going to sit down nice and square, and just push it back into place all the way around. There we go. And hopefully you can see that doesn't look like it's ever been taken off. There's no damage on any of the sides, there's no bending to it. That's all through using that little bit of heat just to ease that off, Like I said, if you don't use the heat, you risk actually bending that metal plate. Yeah, I know you can get reproductions, you can get new ones and just put a new plate on it, but if it's in really nice condition like this one, you want to preserve the original plate. So yeah, that is pretty much ready to reunite with the rest of the Spectrum. I think we'll do that right now. So let's bring the we'll bring the Spectrum back in. Plug the keyboard connections in like that. Gently drop that down. As you can see, even with the heatsink on, that goes together nicely. We'll put the screws back in it now. I'm glad I did that now, because it just reminds me, the last thing this needs is I do need to find one more rubber foot just to replace that missing rubber foot there, but we can do that later. But that is hopefully the actual 48K Spectrum completely finished. We still need to sort its power supply out, and we still need to sort that joystick adapter out and see if we can do anything with that, and then hopefully this should be ready. Let's give it a quick we'll give it a quick test. We'll connect it up like that. I'll get you up on the screen. Let's switch on. Okay. There, if we press enter, let's try. We press print, and then we can just go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, Q, W, E, I, T, Y, U, I, O, P, A, S, D, F, G, H, J, K, L, Z, X, C, V, B, N, M. Let's see if symbol shift works. Symbol shift works. Let's see if space works. Space works. Cap shift works. Enter works. Obviously, that's not going to run as a program, but enter works. So yeah, we seem to have a fully working ZX Spectrum, so we better do something about that joystick and about that power supply. Right, it's about time we did something with this. We did something with the power supply. Now, we haven't actually tested this to see whether it works yet, but what I'll say is it's not really in a good state to even apply power to it. This is virtually a complete short here. I'll just get you zoomed down onto that so you can actually see what we're dealing with. As you can see, it's obviously had a break here and someone's done a repair in the past, but we need to do something better than that. We can't let it go out with a repair like that on it. And the other side's the same, if you look. The barrel connector there, if you look, someone's done exactly the same thing. So we need to sort that out, and we need to see if the power supply actually works at all. So what we will do, we'll go inside it. Now before I even start this, I will say we are going inside something that's mains operated here. Don't follow what I'm doing unless you're actually confident working on main supplied appliances. You know, it just goes without saying that there is, you know, you've got an obvious hazard here. Screw, that's too big. Where's my small? Let's try that one. That gets them. Like I said, you have to be careful when you're working on power supplies. I wouldn't recommend anyone that's just into this repairing computers really repair power supplies. I mean, there's plenty of, you can buy replacement power supplies for the Spectrum, modern replacements, and unless you know what you're doing, you're probably actually better off getting a modern replacement and just keeping the original just as so the computer's complete, you know, and actually using a more modern power supply. But this one, we will see what we can do with it. This should be repairable. I mean, the casing itself's not damaged or anything. Let's get inside it. They are incredibly simple power supplies, these. Put the screws to one side. It's a unregulated DC power supply. Just one smoothing capacitor, a couple of diodes, and the transformer itself. That's all that's in these things. What we will do, we will desolder and they've got a horrible foam all the way over there, connection there. Right, what we will do is we will desolder the wires off the PCB before we do anything else, and then at least we can test the output from this thing. There we go, that's the positive side out. Just get a bit of foam away from there. This is the negative side. There we go, that's out. And we can remove, that's the cable. Now if it was just a break, you're on one side of this, like if that was just the break there, what I have done in the past is actually taken the grommet off there, basically just slid it down, made the cable slightly shorter, a little bit of super glue to refix it, and fixed it that way. But when it's in a state like this, when both sides are broken, you're actually better off if you can get a replacement for it. And what I do, basically whenever I've got any old wall warts or power supplies that are no good, I always salvage the cable off them. I mean, you can't use them all for Spectrums, but the DC jack used on a Spectrum was actually used on a lot of things. It's a very standard size jack. Even though the polarity is different from most things, the actual size of the jack is actually one that you find a lot. So they all go in a box basically for replacements when one's bad on a Spectrum. So I do have a replacement cable we can fit, but there's no point fitting that until we've actually found out whether this thing is in working order or not. So what we will do, let's grab the safe block. These have a couple of names. Some people call them a quick connect, some people call them a safe block. But basically all it is, it's a very simple, safe way of connecting something that doesn't have a plug on it. So it hasn't got a UK 13 amp plug on it. and basically what we've got is a UK 13 amp plug to some safe terminals for actually energising things like this power supply. So we'll get that plugged in. As you can see, that's plugged in, and all we do with this, let's get that old cable out of the way. I can go into my scrap cable box. Just connect the wires. They're basically just spring terminals. We connect the wires in like that. There's a 3 amp fuse up there, and basically when we shut the lid on that, that will energise the transformer there. And then we can just take some voltage measurements. We'll get the meter in. Now I do expect this to be higher than the 9 volts that the computer's meant to, that the power supply is meant to be kicking out, because it's offload. Like I said, this is not a regulated power supply. But what we can do is I've actually got, if I can remember where I've put it, I've actually got a simulated load for a Spectrum, which we can use to test the to actually test whether the power supply is going to work under load. First things first, though, let's just make sure this thing is actually working. That, you know, we could have a case where the transformer could be bad. We could have a bad diode on the rectifier there. I've never actually ever seen that capacitor bad in one of these. I don't think it really gets very highly stressed. But switch on the meter. Oops. There we go. Hopefully you can see that. We'll put this down so it's got power. Right, so that is now energised, so we've got to be careful because the back side of that is actually alive with mains. We'll connect our negative up, connect on there, and we've got 12.7, yeah, we've got 12.7 volts there. Like I said, that is completely off load. Now if we put, if I can find it, if we can put the simulated Spectrum onto there. Now where the hell have I put it? Sorry, you'll just have to bear with me a second, because I'm sure I had this on the desk ready to do this, and I can't remember what I've done with it. That's what I've done with it. I've put all this stuff in front of it. Essentially, it's just a resistor on a Spectrum style connector there. And what I use this for, like I said, it simulates the amount of load that like a 48k Spectrum produces on the power supply. So it's just a good way of testing Spectrum power supplies. Now what we'll do, I'll find a couple of crop leads, and we will we'll connect that up. That's one. I need another crock lead. That's one. Ah, there's another. Oh no, that's not good for us. Where is my other standard crock lead? Come on, where have you gone? Ah, there you are. You're hiding down there, aren't you? No? No, that's just a piece. Ah, there it is. Sorry about this, folks. You drop things on my floor sometimes, you never find them. Right, so we've got two crock leads. So what we can do, so this is designed to for a Spectrum power supply to actually plug into. But obviously, like I said, we haven't got a lead on this yet. So we'll connect it up with crock leads. So basically we'll connect a crock lead on that side, we'll connect a crock lead on that side. Oh no, that's not going to work. Right. Obviously we don't need to worry about polarity on this. We'll connect a crock lead on that side, there onto the positive side. We'll connect that there. We'll connect that onto that side like that. So basically put the load across the power supply, and then if we measure the output from the power supply then, because like I said, this is as though it's actually got a spectrum running on it. And let's measure what we've got now. There we go, that's what we want to see. 9.2 volt, 9.2 volts, that's absolutely perfect. We could actually, there is a way we could drop that. The 7805 voltage regulator, it's not happy with like under 7 volts on it, but anything over 7.5 volts they're actually perfectly happy with. And the lower you get it, or the closer to that, the cooler the 7805 is going to run. And one of the things we want to do is try and get this computer to run a lot cooler than it did originally. That will preserve, especially things like the ULA that run ultra hot. We want to see if we can eliminate as much heat from the computer actually as possible. That's one of the reasons actually why it's a good idea to take the 5 volts away from the modulator. Because the modulator is doing absolutely nothing apart from it's using 5 volts, so it's putting more load on that 7805 reg. So basically, yeah, I am perfectly happy that that power supply is going to work quite nicely. We'll switch off the safe block. I'll disconnect my load there. That does get quite hot actually. But it is great for just doing a quick test like that, just to ascertain that the the transformer is actually, everything's viable. You know, we know that the power supply works. We know that it works under the same load as a Spectrum would give it. Well, essentially, it's mimicking, say, a 48K Spectrum and perhaps, you know, a joystick adapter or something like that. It's around about the 800 to 900 milliamp draw that gives. Like I said, it's around about a Spectrum with a say a joystick adapter or something connected up. So it gives it a real load test. Okay, so we're happy now that this power supply is going to be good for us. So we can disconnect the safe block and I can get that out of the way. We've got our new power lead here, and hopefully these wires are going to be long enough. The one thing is that because basically we are using something that's been reclaimed, we may have to do a little bit of work to get it to actually work. Like, I have a feeling that one of these wires is going to have to be extended, but that's not, like I said, that's not a problem. What we do need to work out is which one of these wires goes to the centre, which is negative on the Spectrum. There's my strip them off. There we go. Set this to its buzzer. Now, is one of these marked with a stripe? Yes, that one's marked with a stripe, so let's connect onto that one. Let's see. Right, so what we know is the one with the stripe there is the one that we have to go to the negative, because it's centre negative to the Spectrum, not centre positive like a lot of things are. So we know that wire. Let's double check it. But it looks like the wire with the white line on it is our centre, which, like I said, we will call negative. Yep, that's right. And I think we're going to have to extend that wire very slightly because it's just going to be a little bit on the short side. So what we will do, where's my in fact, we can use a piece of the wire that we're taking off. I don't need very much. Okay. Now we said the one with the stripe on, didn't we? That one. Oops. I'm going to have to just strip that a little bit more. There we go. Cross them over. I'll just twist them together like that. So we've got a flat twisted join. I'll just zoom you in so you can see it. So basically what we've got is we've got a flat twisted join between those two wires, and if we grab the solder and the soldering iron, we can just, oh sorry, you can't even see what I'm doing there, sorry about that. We can just go in, we can flow those together with a little bit of solder like that. A little bit of extra on there we want to get off. There we are. We've got a nice tidy join there to extend that wire. And what we will do is we'll just add a little bit of heat shrink over that, just to make it absolutely perfect. Because obviously we don't want that shorting out inside the power supply. So we just cut a little piece of heat shrink. Slide that over like that. Hang on, let me zoom you out a little bit so you can see what we're doing. There we go. So I'm just getting a little bit of heat shrink over the top of that. There we go. Then we just need to shrink that down. Okay, put that out of the way. So that's now ready to go into this power supply. The only thing is that connector there is just going to need a little bit of work to allow it to fit actually in the hole there. Now what I think we can do, if we get a knife, I can just pare a little bit of that away so it's actually going to fit down into there. As I said, we are using a connector that was never actually off the spectrum, but so we basically have to make it fit. I'm just going to try and take a little bit of the rubber off from here so it's a bit smaller going through. Of course, your problem is you've got to be careful, because if you take too much off, you risk cutting into the wires, and we don't want to do that. There we go, that should do us. We've taken enough of the plastic out there so that we can actually push that. I need a tiny bit more out actually. Take a little bit more from the other side. Like I say, I've got to be super careful we don't cut into this too deep and actually cut into the two new wires, or else we're back to square one. There we are. Just needs a little bit on that corner. There we are. Scrape that bit out. Right, that should fit now. Keep your fingers crossed. I'm going to have to take a little bit more out from there. Put in like that. Let's try taking a bit out from this side. There we are. Right, that should do us. So you don't want to take too much out, but you've got to take enough out that you can actually get this to push down into the original groove in the power supply. There we are. That's going in now. Let's get a screwdriver and I can just use that to push that home finally. That's it. And let's make sure that the lid actually goes on. Make sure them wires are inside or else the lid's not going to go on properly. It's just showing a little bit proud there. Yeah, I'm just going to have to see if I can just run this along there. Take a tiny little bit of the insulation out from there. Okay, let's try that again. There we go. That's the new card fitted. Hopefully you can see that okay. That looks as good as the original. Nice and tight in there. Right, so we need to wire it in now. Now if we're lucky, we'll just tin that up and we should be able to just sneak the wire back through the original hole. Okay, that's that tinned up. I bring that wire around the back. And there we are. That is reconnected where the original one was. Put my hand down a sec. And now we've just got to deal with this one. Like I said, unfortunately we did have to extend it slightly because obviously in the transformer this was using originally, it didn't have to go quite as far as it does in this one, but we can fit it in quite nicely around like that. And we'll shove that hole, that wire there into its hole. Just solder that in place. Okay. In fact, we'll just add a tiny touch more solder there. Okay. Excellent. So that's looking pretty good in there. I think we can put the cover back on that. touch. Oops. Out you go. Go on, get in the right hole. There we go, that's better. Come on. Ah, there we are. Sometimes it can be a bit of a pain to get them to actually start. Then come on. Another one that's been a bit of a pain. There we go. It's in this time. There we are. So that is the power supply with a new DC cable on it. I suppose what we need to do now is stick something on that end. And I have got a new plug. Well, it's not a new plug, but it's a good one. So we might as well fit that. Okay, we're going to need to change the fuse in it because we only need a 3 amp fuse for this power supply, not a 13 amp which is in here already. Let's see if I've got some 3 amp fuses in my... there we go, thought I had. Let's get a 3 amp fuse out. The 3 amp fuse. Right, now I have shown this on my channel before, but there's a right and a wrong way to wire a UK plug, and I see them wired wrong more than I see them wired right. Essentially what we need is, if you look at them 2 wires there, these are how they come from the factory. Back when the Spectrum was produced, it didn't come with a plug on the end. You was expected to fit the plug yourself. And basically the wires would literally just cut to a length and tinned, and actually weren't intended to be used like that. They were intended to be cut down and fitted to the plug correctly, but no one ever did it. What we want when you actually insert it in the plug, you want the live to actually be fairly short. So we want to cut that live down by quite a bit. Basically we want to cut that much off there, and we want to leave the neutral longer, but that's still too long, so we just snip that. That's a lot better. We will strip the live. We'll go in there like that. Sliding off the terminal for the live wire. Push him in. You want to make sure the wire is right in so you can't see any copper showing. So that's right in if you look, and I'll tighten that screw up. Now if you look there, can you see how that wire is very short? There's no extra length on it. The cord will grip there and there's no extra length. And we take the neutral. This is the blue wire. And we connect that. Again, we don't want to see any of the wires showing. Tighten that in like that, push that down. If we're looking there now, can you see that? You see how there's more wire on the neutral there than there is in the live. We'll do up the cable grip. There we go. The reason you do it like that is because forever, if the cable's to get yanked, it always pulls the live out before it pulls the neutral out, which is a safety, basically. Because if you pull the live out and then someone goes, oh, it's not working, I'll have a fiddle in there and find out why it's not working. It's dead, they can't get a shock off it. As where if the neutral was tighter than the live and it pulled the neutral out, you could do the same thing. Someone go, oh, it's not working, I'll have a fiddle in there. There's still a live wire in there, they touch it, they get a shock. That's the reason why a UK plug is wired like this, and you always make sure that the live is short, so if the cable's ever to get yanked, the live pulls out before either of the other two. Obviously this is a double insulated appliance, so you only have the two wires. If it wasn't and we had a third wire for the earth, you always make sure that the earth wire is the wire which will pull out the last. So it pulls the live out first, it'll pull the neutral out then, and then the earth wire is always the longest, so that's always the one that gets pulled out last. The number of UK plugs with 3-core wiring that I look in, and the earth is as tightly pulled as it possibly can be, and there's a load of slack on the live. And the reason being that because it's been cut straight and no one's done that and deliberately cut the live shorter. Just you know, like I say, if you're going to wire your own plugs, it is really good advice to take. Anyway, the next thing we want to do is we want to get rid of that 13 amp fuse out of there, because we don't want a 13 amp fuse just for a Spectrum power supply. We'll put a 3 amp fuse in. There we go, that's better. We can get the plug back together. Okay, and this Spectrum supply should be now ready to supply a Spectrum. We'll give it one last quick test. We'll just plug it in, and we'll just use my tester here. I'll just do a quick offload test, and then we'll plug it into my quick little load tester. But what we should have is the outer case there should be our positive. And it will help if I turn my tester actually back onto the voltage range. But the outer there should be positive and the inner there should be our negative. So if I hold my test probe on like that and we use the inside and touch there, we can see we've got 12.81. Like I said, that's offload voltage. If we put my little Spectrum dummy load in, this is where I find that that one doesn't fit this. Anyway, let's connect that to that. Connect that to that. Right, where's my other wire gone? Ah, there it is. Connect that to that like that. Connect that one there like that. We can connect that there. Now we will get a minus voltage because I'm connecting the, in fact we don't have to, I'll just swap the probes around there. Okay, like I said, this is showing an on-load, and there we go, 9.0, yeah, about 9 volts there. That's absolutely spot on. So I suppose one quick final test is, will it power up the Spectrum? get you up on screen. So we still have work to do on the Spectrum, obviously, but we'll get the Spectrum in. Connect Spectrum up. So that's the Spectrum connected back up. That's the Spectrum connected up to its proper power supply, its original Spectrum power supply. And if we switch on, there we go. So that's the power supply, fully rebuilt, ready to go. Okay, so the only thing really we've got left to look at is this joystick interface. Now, as I said before, and thanks to the wonders of YouTube, someone's actually mentioned that just because it's got the smaller connector like that, a la ZX81, doesn't mean that it isn't a Sinclair Spectrum joystick interface, because apparently some of the manufacturers just use the smaller edge connector, because it still connects all the pins that you need for the actual joystick interface. Now, in all my years of messing with these old computers, I never knew that. I always thought that the wider one was for a Spectrum and the smaller one was for the ZX81. I didn't realise these actually worked with the Spectrum. So much so I went through a box of random ZX81 joystick adapters that I had, and I found another one. That one works perfectly as a Kempston joystick interface. I found an identical one to them as well. This one's faulty. I'll probably have a look at that. But I mean, that's another two ones that I can use with Sinclair Spectrums rather than just the ZX81. So I mean, that's the standard. This is one of my. This one's iffy as well, actually. But that's your standard connector, full edge connector for the Spectrum. If you look. But providing you get the slot lined up, like I said, it'll fit in the back of the Spectrum, no problem, and it does work. Well, it should work anyway. Like I said, this one is faulty. Left and right work fine, fire works fine, but there's no up and down action. So we'll have a look and see if we can find out what's actually wrong with this. These things are incredibly simple. So it shouldn't be a major issue to repair. It just depends what glue logic we've got in here. If that's the fault, 'cause it isn't necessarily going to be the fault, and if it is the fault, have I got one I can stick a replacement in, or will I have to order one? Let's get inside it and let's have a look. Take the back off. There we go. Put the case to one side and let's have a look what we've got. So we are talking super simple. We've got a 74 LS 366, I think that says, and we've got a 74 LS 00 there. So, I'll grab my glasses so I can see a little bit better. Right. First thing I want to have a look at is if we've got any dry joints round the actual joystick connector there. Let's see if we can get that a little bit closer. And unfortunately, the solder joints on that look absolutely fine. Let's just have a... There's one pin there looks a little bit iffy, but I still think it is making a reasonably good connection. I'll just I don't know if you can make that out. There's just one one connection right there that looks a little bit iffy. I think it's fine, but I think we will just reflow that one. The other place to look is all the pins along here, because that's your edge connector. It's basically places where strain's going to be put on. That's going to get strain out as you're pushing your joystick connector in and out, and obviously these pins are going to get strain on them when you're pushing the actual interface into the back of the Spectrum. So we want to really carefully inspect all these pins along here, see if we've got any bad joints. There's a couple of pins up here which don't look very well soldered. To the point, I think what I'm going to do, I'm just going to reflow all the solder joints on it as the first thing we're going to do, because there's a couple of, like those two, I said there was one down there. To be honest, all the pins on the actual ICs look okay, but it does look a little bit iffy. They just look like there's a couple of iffy joints around here. And like I said, there's one solder joint there which looks a little bit dodgy. So I think as a first thing, I'm just going to go around it and I'm going to redo I will redo all those solder joints, just so we can be happy that's not going to be the issue, and then we'll just do a quick retest of it. This is the one that looked a bit iffy. Let's have a quick look at those. Those look a little bit better anyway, especially that one. Like I said, there was one there that looked a little bit on the iffy side, so I'm happy we've done that. And then it's just going to be a case of doing, so there's a few on here that they don't look brilliant, so it's not going to do any harm just to reflow these and add a little bit of extra solder. Whoever did this seemed to be quite stingy on the solder when they actually assembled it. Let's give my iron a quick clean. I need to get my head a little bit closer, and with the light where I had it I couldn't actually get in to see what I'm doing. That's better. Hopefully my big head's not getting in that shot. That's the top row done. Let's just whiz down the bottom row. Not going to do any harm just to redo them all. Especially considering, like I said, this is a part that gets quite a lot of force put on it because you're constantly, well not constantly, but you're plugging in and unplugging the connector. And there was very, very little solder on those pins really. There we go, that looks considerably better. So I don't know whether that was actually at fault or not, but it's one of them ones where it's definitely not, you know, it's, if we didn't have a dry joint there before, because of the little amount of solder that was on there, that is definitely somewhere that could possibly fail in the future. So just adding that little bit of extra solder, like I said, we've reflowed all the joints if we did have a tiny little bit of a dry joint and that was causing the issue. If not, like I said, we've just reinforced that for the future, so we've just made a bit of a better job of the actual soldering that was on there. Same with the connector there. Like I said, that's the connector which is going to have a bit of strain on it. Probably not as much as that connector, but we've just reinforced all them. Like I said, one of them did look a little bit on the iffy side. What I'll do is we'll get this connected up to a Spectrum, just as it is like this, and we'll give it a quick test and see whether we've made any improvement. If not, I'm probably suspecting it's going to be that 74. Well, you've got 3 diodes in there. We can test the 3. In fact, shall we do that now? Let's quickly test them 3 diodes, because those would be dead easy to swap out if one of those is faulty. And get the old tester in. It's a case of doing the simplest first. And then going to the more complex faults. And a blown diode's a nice easy thing to sort out, so we'll quickly test these diodes. Which way round are they? We've got a common, right, yeah. Well, I click on there. I should be able to test them all. That looks about right. That looks about right. And that looks about right. Now, I'm expecting them all to be fine, but we will just do, we'll just test them for reverse. Connect on there. We shouldn't get any reading at all. Nothing. Nothing there. And last one. Nothing there. So yeah, those diodes are fine. So that kind of means if it doesn't work now, it's going to be one of the 2 ICs there which is faulty, and I suspect it's probably going to be the 74 LS 366, which I'm pretty sure I haven't got any of them. I've got a circuit diagram. What makes me suspect that one rather than that IC there? I've got a circuit diagram with a Kempston interface here. Now it uses different ICs, but that doesn't really matter. They're still basically doing the same things. We've got the 74 LS32 there, and if you see, it's just basically being used to combine some signals. I think the 74 LS 00 there is basically doing exactly that job there. The 74 LS 366 is doing the same job as the 74 LS 240 on this circuit diagram. That's if this doesn't work now, that's what I actually suspect's probably faulty. Like I said, I don't know whether I've got one of those in stock or not. I'll just pause the camera. Like I said, we'll get this set up with a test spectrum, and we'll see what whether we've made any improvement just by reflowing all those joints, because there were a few crusty ones in there. So back in a sec. Okay, so we're all set up with the with basically one of my test spectrums. What I'm going to do, I've got the interface plugged in the back there. I've got it connected up to a joystick. I'm going to run Jetpack because that's what I used when I was actually testing out and discovered there was no up working. So we will run Jetpack and we'll see whether we've got we can actually get the guy off the ground. I'll press enter. We'll get that loading. You see Jetpack is loading, and I'll just pause the video and I'll come back as soon as Jetpack is actually loaded. I'll just bring you back just before it finishes loading so you can actually look at the wonderful Jetpack screen art. I do think it's really good for a 16K game, Jetpack. We're nearly there now. That's a really nice thing about loading from a tablet. You can actually see how much you've got left of the load to go. There we go. And this is one of the reasons why Jetpack's quite nice to use as well, because you've got Kempston right there on the so we're one player game, Kempston joystick. Let's start the game. Okay, I can't go down. I am now stuck up. So something's changed, because before I could only move left, right and fire, and I've now flown up to the top of the screen. But I can't move down. And obviously I'm stuck right at the very top of the screen, so resoldering those joints seems to have possibly brought back up, but we are now stuck, as you can see. So I can fire fine, I can move left and right absolutely fine, but what I can't do is then come back down. Yeah, up and down just well, you're just flying up. Like I say, I weren't doing that before. All I was doing was getting stuck before on the ground. So we've made some improvement, but we've not exactly fixed it. Let's just switch that back off and I'll get you back down onto the setup. So I have a horrible feeling that it is indeed that you can unplug this now, because this joystick has been tested. I do know that joystick works fine. So we definitely do have another fault on this. Like I say, I've got a horrible feeling it's going to be that LS366. I don't think it's going to be the 74 LS00, because if that wasn't working, if there was a fault in that, I don't think the joystick controller would do anything at all. I have a feeling it's that's at fault. Let me go and have a quick look in my stash and see whether I have got a replacement for that, but I don't think I have. Back in a sec. Okay, well, I've scoured my 74 series Logic IC collection, and I cannot find a LS633. Sorry, 366. I've looked absolutely everywhere, and there's a chance that I've probably got some in my other stores, but that's that's at a different location, and I don't really feel inclined to travel out to there tonight to have a look. But what I did do is, I showed you that controller before, that other Kempston interface that I've got. Well, I took the faulty one apart. This one, actually, dead easy to take apart. I'm sure these are based on a cartridge which has been modified. It does look very much like a C64 cartridge. I think the cases of these are actually, like I say, a modified games cartridge. It's just been repurposed. But anyhow, this is the faulty one, and I took it apart, and we've got two 74 LS 366s in there. Now this is faulty, but what I'm hoping is that the fault is actually only on one of those two ICs, not both of them. I wish actually I had my Speedmaster out. My Speedmaster's buried up in the attic at the moment. It would take far too long to actually extract it. If no one's seen that, it's actually an EEPROM programmer, but it's got a component analyzer function on it, and it can actually test most 74 series logic ICs. It would be dead easy then just to throw them in there and see which one was faulty, or if one of them's good, and just swap it into that board. But seeing as, like I say, it'd be too much of a hassle to actually dig that out, and this is no good. I'm going to pop them two ICs off there. I'm going to stick a socket in there. I'm just going to try those two ICs in that board and see if either of them actually still work. So there's a good chance that the fault is just on one of them. I'd have to reverse engineer the circuit to see how they've actually wired these. But like I say, I'm hoping that the fault is just one of those, and one will work. I can stick it on there, and then I can go and have a hunt in my other stores and see if I've got some new ones, and I'll just put some new ones in there, and then I've got another good spare Kempston interface. So without further ado, we better whip these off here, whip those off there, and see what we can do. Let's get the oops, yeah, just realised I've just put all that on top of my flex for my desoldering gun. I've got to I really got to tidy my workbench up. It's getting a little bit redonkulous again. Right, let's get this off here. Right, let's have a go at that. Just very gently, just give it a quick try with a screwdriver. Oh, look at that. That's what I love about this desoldering station. Straight off. No messing about. Straight off that. So orientation, pin one's that way. We'll stick that to one side. We'll stick a socket in there. See, when we want to swap in a couple of chips, there's no point soldering one of those. I find it whenever you take an IC off, you're always better off putting a socket there, because it means that in the future, I'm not going to use a. Oh, these aren't too bad actually. I didn't think these were dual white, but they are. Let's get one of them. I think that's the right one. Double check. No, I need one bigger. And what I was saying is, if you're taking the IC off, it's a bit of a no-brainer not to put a socket on there, because every time you work on that board, you risk damaging tracers, lifting pads. If you've put a socket in there, even if you've got to swap a few ICs in there, you're not creating any more potential to actually damage the socket itself. And these aren't expensive IC sockets. They're some cheapy ones that I got hold of, but they are actually dual wipe, so they're not too bad. They're better than what like not Sinclair, Acorn were using in the BBCs, because some of their IC sockets were a bit on the poor side, I will say. Right. In fact, quite a few computer manufacturers cheaped out on their sockets. Well, let's get this in here. Best thing to do, if you can get one side in, it makes it a lot easier just to sneak the other side in. There we go, that's down flat, and we've got the pin to the right side. So we'll get that soldered into position, then we'll whip them two off there, and we'll give them a try. Put that bad one up there out of the way. And what have I done with that piece of... ah, there it is, a bit of solder I had before. Give the iron a quick clean. We'll get this... in fact, that socket's holding in its holes quite nicely, so I don't need to put anything behind it. Sometimes a bit of blue tack or your finger just behind it just while you solder the first pins, but in this instance it's actually holding in nicely. On it. Okay, there we go. Put that away. So we've now got a socket in place on there, so we can try. See, I know that at least one of those, they might both be faulty and we're back to square one. See, I don't think it's the 74 LS00 that's at fault, because if that was faulty I don't think the interface would actually do anything. I think it'd actually be stuck. I'm pretty certain that is the IC that's at fault. Anyway, we'll whip them two off here, and at least we've got a chance. Thinking about it, I mean, if they had a faulty joystick, it's most likely to be that one. I don't know, I know it uses both. It could be neither of these could be any good, but like I said, it's worth a quick try. I suppose what I could really do is, if these are no good, is whip one off the one that I know works, and then just replace that. Go back and do that one again. That's better. First one done, let's do the second one. Bit of a bigger trace. Same with that one. This one's a bit of a bigger one. Okay, let's see if those will pop straight off. Let's have a go. Yeah. And very, very gentle. You don't want to use too much force. So if you're having to force the chip up, you haven't removed enough solder. As you can see, those are sliding up. There we go, that's the first one out. That's okay there. Let's just try it on this side again. Yeah, that's okay. And that's that one out. So we've got the two salvaged ICs. Like I say, I'm not holding out that much hope because that was a faulty controller, but there could be a chance that it's only one of those that's actually faulty, the other one's fine. I'll just quickly pause you while I get this all set back up again, and we'll see whether one of those is going to actually fix the problem. So back in a sec. Okay, as before, I've got Jetpack loaded up. We'll get up onto the screen. So we want to pick option 4 for the Kempston joystick, and 5 will start the game. Oh look, I can fly up. I can move forward, I can move left and right, I can fire up. Excellent. So yeah, I was right, it was just that I'm not very good at this game, I will admit. I can never pick the bloody I can never pick the bits of ship up. But yeah, that seems to be that has fixed it, and that's the first one of them two ICs. That's the first one of those we actually tried, isn't it? I won't bother trying the other one, seeing we've actually seemed to have got a success. What I'll do is I'll put the interface back together, and we'll have a go with the whole system together, and actually see how well it works. So back in a sec. Okay, quick idiot mistake, folks. As I was saying, it's a very good idea to put things in a socket, but unfortunately sometimes you drop a ball doing it. We know it all works fine, but when I actually put the controller together, put the case on it, as we can see, we can't actually put the case back together. It's only slight, but unfortunately with it in the socket there, there isn't enough room for the actual top of that to go back on. So what I'm going to have to do, I'm going to have to desolder this again, and then resolder the IC directly back down onto the board. I didn't think we'd have an issue. I thought there'd be enough clearance, but unfortunately, in this instance, no, there isn't. So we'll take that IC back out. We'll have to whip that socket back off. I think I should hopefully be able to still use this socket on another job anyway. Hands shaking at the moment. Steady on the bench. Right, that should be all free. There's a little bit of solder on that one. And on that one. Right, let's see if that'll come back out now. Sometimes you feel a right fool when you do something like that. Let's see if we can get this. There we are. And that's come out super clean, so I can even reuse that socket. That can just go straight back into my socket box. And make sure I put the bad ones out of harm's way. So I don't actually think I'm going to have that issue in that other controller, to be fair. I think there's enough room in that other controller to actually put 2 sockets in there. It's just this. It's only because the shape of that socket, sorry, the shape of that case. If that case didn't have that shape there where it steps down, we wouldn't have had a problem. It's just I should have checked before I soldered everything into place. There we go. So that's that done. Hopefully this should fit. This should fit together now. Let's give this another try. So that fits in there like that. And the top. There we go. That's better now. That actually fits together. I won't just screw it together now, because I'm just going to give that board a quick clean and get the flux residue off it. And I'll get that screwed together, and we will go and give it all a test. So again, back in a sec. Right, well I thought we'd come into the office because we've got a little bit more space in here. It's actually a little bit easier to film both the Spectrum and the screen at the same time in here, unlike in my workshop. So we have the finished Spectrum here, and as you can see, I actually found it a replacement foot, so it does actually sit it sits square on the table now and doesn't rock. That's actually off the bottom of an old ZX81, but they use exactly the same little square rubber feet, so it doesn't really matter. It just means that it's got a full set of 4 feet on it now. We've also got the power supply that we've rebuilt with its new low voltage cable with a decent connector on it, not all taped up, and the strain relief into the thing is decent. It's not all taped up. Put a decent 13 amp UK plug on there with a 3 amp fuse in it, so that's all ready to go, and that's correctly wired as you saw. So the last thing, oh, and we've got the what have I done with it now? Oh, there it is. We've got the repaired, well, hopefully repaired. We haven't actually tested this yet, but we've got the well, we tested it. We haven't tested it since I had to take the little socket out and put the IC straight onto the board, but hopefully we didn't do any damage doing that. So we'll give this a quick test. We'll get it all connected up now, and we'll give it a final test. So we'll plug the joystick adapter into the back like that. We'll connect up to my test monitor I've got in here like that. We'll get the power supply plugged in. So we've got the power supply there plugged in. We'll get the power lead up to that. I've got that strap around that wire. There we go. We've got our power wire. And finally, we need something to play off. I've got my little tablet here, all set up, ready to go. So what we will do is we'll connect into the ear socket because it's listening for programs. And then all we've got to do, I'll get you up on the screen, so hopefully this is just going to fire up. A bit. Oops. There we go, you can see everything now, can't you? And we will plug that. We'll plug this in and hopefully we'll get the computer working. There we go. Let us load some software on it. Now I've got something on here that's that we should be able to use quite nicely to test the joystick interface. In fact, I'll get my joystick up here as well. This is just my my test joystick. I'll find something a little bit better to include back with the Spectrum, but this will do for testing for now. So all we need to type is J for load, then we need double quotation marks, press enter, and then we hit here. In fact, I don't think we'll load that. Just a second. No, that's not the software I was going to load actually. We'll just reset. I thought, no, that's not what I wanted to. That is not what I wanted to load, because I don't know if that's going to allow us to go all the way around the screen. So let's start that again. We want something that has got both up, down, left and right on the joystick, so we can give a proper test of the joystick. So we'll start that again. Press enter and I will start this again, and what we're going to run is Boulder Dash. This is the original, I think this is the original Boulder Dash. What I'll do actually, because this takes about 4 minutes to load, I'll just pause the video and we'll shoot straight back as soon as this has loaded. Okay, Buggy Blast has actually loaded up, and the reason I'm using this again, it actually has, in fact this is a good game for testing joystick interfaces. If you see, we've got Kempston, Sinclair, ProTech, AGF, which I've never actually heard of, from Fuller. So let's select Kempston. What do we want to do? Select number of players. How do we start the game now? Press fire to continue. The thing with Boulder Dash is it should allow up, down, left and right, so it gives a good test of the okay, I can move. Yeah, look at this. Go up, down, left. So no, I'm not really going to play Boulder Dash, but this does prove the point. Oops, and I've got myself stuck straight away. But it does prove the point. The actual interface it does seem to be working absolutely fine now. So just changing that 366, that 74LS366 has actually solved the problem. With no more problems with that. I'm going to show you one more game on this. It's quite fitting considering what the chap who owns this thing has just started playing about with. So we'll get this reset. And then we want J, double quotation marks to get it to load. Just move that out of the way. Press enter and press play on tape. I'll get you zoomed in onto the screen because you don't really need to be seeing the computer at this point. There we go. Get you up a tiny touch more. There we are. We've got C5 Clive is charging, please wait. Now it's nearly 5-minute game to load this, so what I will do is I'll let the screen here just load up, and then I'll quickly pause the video, let the rest of it load, and then we can get back to it. Okay, we're back and it's just loaded. That's 5 minutes of my life I won't get back. I couldn't even get out to make a brew, being that where I've got my tripod in the office. I couldn't get past I couldn't get past it to without disturbing the camera, but oh well, never mind, we've got it, it's loaded up now. So this is C5 Clive, and you can be a learner driver, Sunday driver, an experienced driver, or an advanced driver. But first let's have a look at the instructions. So that's press number 5. Just in case you can't read this, what we've got is it's one day on the way home from work at a local software house, you chance to meet a man named Honest Les. After a long discussion, Les is successful in selling you a new Sinclair C5 battery car for the bargain price of only £399.99. thinking that you have got the bargain of a lifetime, you decide to drive the car home, but the ride is not so easy. Well, this is basically just showing you how the game works now. So you will use the following keys: Q and A and space to pedal, slash, jump. There is no kit, there is no joystick support on this game. Basically, this just tells you what's on each screen, so we'll skip through these. So good luck, y'all, you need it. I think we'll be a learner driver. I will admit I've had a few goes on this previous to this. I actually have this game on cassette tape. Unfortunately, my original cassette tape version doesn't work anymore. But this is just one that this is just one version that I downloaded. We'll start as a learner driver. As you can see, you basically can't touch anything. You can only go up and down and accelerate. Interestingly, you can't brake. You can grab batteries. You can't go too high or else you hit the sky and die. I've got a battery. And I haven't... There we go. I think we'll just get through. Yeah, onto the second screen. Woo! And this is the farthest I've ever actually got on this game. Oops. I missed a battery, so I'm probably going to run out of power. I guess I ran out of power. Get away from the scary ghost. Why ghosts is going to affect a Sinclair C5, I don't know, but apparently they know. Air crash into a tree. Go on, one last go. Oh no, that's it, game over. Well, I think we'll get out of that because it's a little bit on the noisy side. We'll quickly unplug and just replug. We should bring the Spectrum back up. You can see we've got the nice longer black dot that indicates that it is running as a 42k Spectrum. But yeah, that is basically the repair of this complete. Now I will. Oops. Let's zoom out a little bit. I will get this all packaged up. I'll give it all a good wipe over with some alcohol wipes, get it absolutely clean and sterile, and get it all packaged back up and sent back to its owner, and hopefully you can enjoy this for a bit. What I will do as well is I'll make a disc up, I'll make a CD up with some of these games on it, and I'll record them as a WAV file. So, in fact, what I'll try and do is I'll try and author it with a CD audio track on, so that we can actually just stick them into like a portable CD player or something like that and play that into the Spectrum. And I'll put them on there as WAV files as well, so we can put them into a laptop or his PC and run them through that way. So he's got a way of running some software on this. I'll stick that C5 Clive and a few other classics, like I say, onto a CD or some way that he can easily load them into the Spectrum, because I don't know whether he's got a tape recorder or any original software for this, for the Spectrum. I think he just had the computer that he got. But like I say, I'll sort out a CD with some games on it. I'll definitely throw C5 Clive on there for him to have a play with. Anyway, I'm going to leave it there for now. Like I said, I hope you enjoyed this rather long little video on getting this Spectrum back up and back into nice running order. But really, it didn't take a huge amount. It just took a little bit of recommissioning and make it so hopefully it's going to last another 30 years. You know, it's got new capacitors in it. We've changed that voltage reg. We've done the best we can with like the ULA, putting that heatsink on it. Same with the CPU. So hopefully, fingers crossed, this Spectrum should. And obviously, it's got the new keyboard membrane in there, which is a big thing because that is a major failure point on these now. So hopefully, with all that work we've done and the repaired joystick adapter, you should have many more years use out of the Spectrum. So I hope you enjoyed that. Thanks for watching, and goodbye.